So here I'll start by finding out for what values of n is this true. Because I know that as n becomes large, this will eventually become greater than that. So there's only a finite set of values. So if I start with n equal to 1, you'll see that this is indeed true. Because that's 9. So 1 works. 2 would probably also work. 3 cubed, which is 27. 3. So I'm just trying on values and see how far this goes. You can maybe jump certain values as well. 3 to the 4, that's 81. 25. N equal to 4 would be 5 cubed. 3 to the 5, that's 243. You can, of course, use the calculator and just keep multiplying it by 3. That's 125. And if I multiply it by 5, that's 625. So 4 works. And then that would be 729. So this is 2. N is 5. Also works. And if you do n equal to 6, this will be 3125, whereas this will be less than that, because you can see it's around 2100. So n equal to 6 doesn't work. So these are the only values, 1, 2, 3, 4, and 5. Now, we need to satisfy this for all values of these m. And we're looking for the least integer value of m. So I'm actually going to go for the highest value of m, because we know, again, 3 will be, this 3 to the power will exceed that at some point as the n becomes large. So if n is 5, 3 to the 6, so that we know already we've done here 729. And I need to make sure that this piece is greater, so choosing a value for m. Now powers of 2, I mean, maybe most of you know what those are, but if you don't, just kind of generate them starting at some point. 2 to the 8 is 256, 2 to the 9 is 512, 2 to the 10 is 1024. So we need this to be 1024, which means m needs to be 5. So that's kind of the least I'm getting here. Now what you'll notice is for all these other values of n, for example, if I do 4, then this is 3 to the 5. I just did as 243. Here you'll see I just need to get to 256. So 4 would do the job, but 4, of course, won't do the job here. So again, I'm looking at 5 as the least. That would satisfy this condition. And that's also going to work here, because this will be then 2 to the 9, which is 512. And so would be the case with the remaining values. For example, if this was 2 and m was 5, you'll see that this is indeed true. This is 7. This is 2 to the 7, which is 128. So the least integer value of m that satisfies for each of these values of n is 5. And that's our answer.